Okay, good morning. I hope you are doing well. Uh, Today is yet another day that we will continue to do what we have been doing, and I believe all will work out well. So, for the last 3 weeks, we've been revising and working out on paper 1, that is mathematics paper 1, and that is what we will still continue working out on. In this lesson, we are going to go through this topic called differentiation. So differentiation is a topic in Form 4 work. It's a topic in Form 4. It's a Form 4 topic. I know by chance you've not yet done this topic. You have not yet done this topic, but we can go through this topic because it is part and parcel of paper 1, so that you will have time to to start revising for paper 1. So it's a Form 4 topic. It is the third last topic in Form 4, and this topic we are going to do it now. So I hope you are doing well, and I'm also doing well. And in this lesson, these are our objectives, or this is what we need to achieve by the end of this topic. So our objectives will be: number 1, finding the derivative. Finding the derivative. Finding the derivative simply means you need to know how to differentiate. This is just about the same thing: finding the derivative, differentiating, and also finding the gradient function. The gradient function is called dy over dx. That is the first thing that we will be determining. That is the first thing that we are going to be determining. Before the end of also this topic, you must be in a position to you must also be able to find the derivative of polynomial. The derivative of polynomial. When we talk of a derivative, we mean dy over dx of a polynomial. A polynomial, it's not a complicated terminology. It is just a name of an equation. An equation, remember, is made up of more than one element. So it is one but the same thing. The next one that we will be learning is equation of tangents. Equations of tangents and normals. Equation of tangents and normals to a curve. Equations of tangents and normals to a curve. That is, we also be running on the gradient of a curve at a point. The gradient of a curve at a point. We will also be running on stationary points. Stationary points, we also call them turning points of a curve. Turning points of a curve. Also be learning about curve sketching. Curve sketching. And last but not the least, we also learn about application of differentiation in calculating in velocity and acceleration. And the last one will be maxima and minima. Maxima and minima. So in this particular lesson, we may not be in a position to cover everything, but I believe we can be able to go up to this level. We can be able to do the first four. We can be able to find derivative, or we can be able to differentiate or find the dy over dx. We can also be able to find the derivative of polynomials. We can also be able to find the equation of tangents and normals to a curve. But this one is number 4. This comes first as number 3. So our number 3 is gradient of a curve at a point, and number 4 is equations of tangent and normals to a curve. That is what we are going to be doing. So I think we can now start. So today we will do the first 4, and you will find how easy it is. And why are we doing this? I know you've not yet done this topic, but because it is part and parcel of paper 1, and I believe that by August we will be sitting for so many revision, we will be sitting for full papers. I want you to be well equipped with everything that you need to have in mind. Haya basi. So tutaanza with finding the derivative. Finding the derivative. Finding the derivative. Finding the derivative. dy, that is over dx. When we talk of dy over dx, we simply mean that change in y over change in x. Change in y over change in x. How do we go about that? So this is how we go about differentiating. So the formula is given y is equals to ax to power n. Given y equals to ax to power n. This one is a function. This one is a function. Y equals to ax to power n. What we do is that for us to differentiate, it becomes dy over dx is equal to, so this is what happens to this function. We take n, we multiply it with a. So an times a, the power multiplied by the coefficient, is going to be an. So once you multiply a times n, itakuwa hiyo. Then x will remain there, and the power of n will reduce by 1. The power of n will reduce by 1. So it is an, then x remains there, and the power of x reduces by 1. That is simply how we differentiate. That is how we differentiate. The power of n reduces by 1. We multiply the constant, the coefficient here with the power, then x, then n minus 1. That is generally how we approach that question. So what do we mean by saying that? If we have a real number, for example, if we have example 1, and our real number is y is equal to 4x cubic, we have such. So when we have such, if we have such, y is equals to 4x cubic, what we do about such is that it will now become dy over dx is equal to, we've said you take the power n, you multiply it with a. So our n is 3, you multiply it with 4. So 3 multiplied by 4 will become 12. Then our x will remain there. Then our power will reduce by 1. So our power will be 3 minus 1. So that will give us dy over dx is equals to 12x to power 2. 12x to power 2, or 12x squared. That is the first example. We can have another example 2. y is equal to negative a half x to power 12. Negative a half x to power 12. So we have such. So in this case, we will do the same case here. It will become dy over dx is equals to, we will take 12 and multiply it here. So it will be 12 multiplied by negative a half. Our x will remain there. Then our power reduces by 1. And we will end up having dy over dx is equals to 12 times negative a half is negative 6x to power 11. 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 We can do another example. See, y is equal to 2 over 3x to power 3 over 4. Two over 3x to power 3 over 4. So in such a scenario, it will also be dy over dx is equal to, we will take the power multiplied n times a, so it will be 2 over 3 times can also be represented by a dot, 3 over 4, then x to power 3 over 4 minus 1. So our dy over our dx is equals to, this one will be equal to a half, because by 3 1 by 3 1 by 2 1 by 2 2, so it will be equal to a half x. Then 3/4 minus 1 is equal to power negative 1 over 4, is equal to power negative 1 over 4, to power negative 1 over 4. I think we are done with that one. So I hope you've understood. Have you understood? If you have understood, then you can do this. Differentiate each of the following functions. Differentiate each of the following functions. Y is equal to 3x squared. B y is equals to negative 4x to power 6. You can do those two. You can do those two. Have you understood? Do the two and give me the feedback. you done? Are you done, Jenny Jogona? Are you done? Are you done? So, yes, let us check out on the solution of the first one. Y is equal to 3x squared. So what we are going to do in this case, we will find dy over dx will be equal to 2 times 3 is 6, then x to power 2 minus 1, and that will give us dy over dx is equal to 6x. 2 minus 1 is 1, so it will just be left like 6x. And 6x. B, y is equals to negative 4x to power 6. So this one will be equal to dy over dx is equals to 6 times negative 4 is negative 24. X to power 6 minus 1 is 5. 6 minus 1 is 5. And we are done. And we are done. We are done. Correct? The next one we are going to do is find the derivatives of polynomials. Derivatives of polynomial. So when we are talking of polynomials, we are talking of numbers or functions that have more than one element. And a good example of the first function that you can be having is number 1, find dy over dx for y is equals to 2x cubic minus 3x plus 4. We have such. So such we call them polynomial because they are not just one. It's a sequence. It is a sequence. So what we are going to do is in this case, what you do is that you differentiate everything. Okay. What you do is that you differentiate everything. So differentiate ya kwanza, ya pili, ya tatu. So in short, for us to find dy over dx in this case, we are going to find the dy over dx of 2x cubic minus dy over dx of 3x plus dy over dx of 4. That is how we are going to do that. So what we do here, in this case, unatafutanga ya zote. So ukitafuta ya kwanza itakuwa dy over dx itakuwa, what is the dy over dx of this? It will be 6, 3 times 2 6, x, 3 minus 1 is to power 2, then minus this one, dy over dx, which is equal to 3x, or y being 3x. For you to find this one, it is going to be, this is to power 1. Don't forget that x is to power 1. 1 times 3 is 3, then x, then 1 minus 1 is 0. And any number raised to power 0 is 1. We call it a 0 index. Any number to power 0 is equal to 1. So 1 times 3 is 3, so it will be minus 3. Then the constant huwa inaisha, ile 4 inaisha. Kwa nini? Because if we have our function as tuko na 4 na tunataka kupata dy over dx ya 4. Remember this one here, x is to power 0. Hakuna kitu. So what is 0 times 4? It is 0. 0x to power 0 minus 1 negative 1. So any number x to power negative 1 times 0 will become a 0. So our dy over dx will be equal to a 0. It will be equal to a 0. So tutaachia hapo. Equals 6x squared minus 3. So you can see the power is reducing. This was to power 3. It is after differentiating, it becomes to power 2. This one with x to power 1, it reduces to x to power 0. And the one with x to power 0 becomes a 0. So it is just reducing like that. So we can do another example. Find dy over dx for a y is equals to x to power 4 minus 3x squared plus 7, and b y is equals to 5x to power 4 minus 2x to power 5 minus 7x cubic. We'll do those two. So you can do those two, we can do the two. So we've said that when we are differentiating, dy over dx is equals to, so here we have 1. So 1 times 4 is equal to 4. X, the power of 4 reduces by 1, so it will be 3. Minus 2 times 3 is 6. X, then the power reduces by 1. 2 minus 1 is 1. There is no need of writing 1 there because 2 minus 1 is 1 and x is already to power 1. Then 7, this is a constant, itaisha. na tumeprove itaisha. Kwa nini? Because it is already to x to power 0. So ikikuwa 0 times 7 itakuwa tu 0, itaisha. We are done. This one is dy over dx is equals to 5 times 4 is 20 x to power 3. Why 3? 4 minus 1. Then minus 5 times 2 is 10. 10 x to power 5 minus 1 is 4. Then minus 3 times 7, 21 x, 3 minus 1 is 2. You can see the power is reducing by 1 as we go down, as we move across the equation. The power is reducing by 1. 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 You can do another one. The last one. The last bit of this question is differentiate y equals x plus 2 x minus 1 with respect to x. With respect to x. So when you are told to differentiate, we said it is the same thing as being told find dy over dx, or find the derivative, or also find the gradient function. So when you are told to find the gradient function, find the derivative, find dy over dx, it means the same thing. So what we are going to do in this case, we have y is equal to x plus 2 x minus 1. So this function here, we are first going to expand. You cannot find the derivative of this function when it is like that. You have to expand it. And once you expand it, you get y is equals to, you take x, you hold it, x minus 1. Then you take plus 2, you hold, then x minus 1. Remember, this one is a quadratic identity. So y is equals to x times x is x squared minus x plus 2x minus 2. So y will be equal to x squared minus x plus 2x is plus x minus 2. Now we can find the derivative of this. This is the one we are going to find the derivative of, that one. So what we are going to do is that it will be dy over dx is equals to, this one here is 1, so 1 times 2 is 2, and x remains there, 2 minus 1 is 1, then plus, if we differentiate x alone, it will give us 1. How? You may ask yourself how. Let us say we have y is x. So once we have y as x, this is the same as y equals to 1x to power 1, or 1x to power 1. So dy over dx will be equal to 1 times 1 is 1. Then we have x. The power of x reduces by 1, so it will be 1 minus 1. So dy over dx will be equal to 1x to power 0. So remember, any number to power 0 is 1. So 1 times 1 is equal to 1. So dy over dx is equal to 1. So that is why we have said when you differentiate x, you get a 1. And you are done. And you are done. You are done. You are done. let me get you some questions that have been done in KCSE. You do them, then we proceed to the next thing. The next thing we are running on, finding the gradient of a point in a curve. So there is a question that was assessed back in the year 2005. And the question reads, a curve is represented by the function (1 over 3x cubic plus x squared minus 3x plus 2). A, find dy over dx. 1 mark. Tafuta hiyo. Tafuta hiyo unipatie jibu. So, Anura, you are asking a question. Why is an independent function or an dependent function for the before example? Okay. Why is always the independent function while x is the dependent function? So when we are dealing with functions, y is independent while x is dependent. So do that question and give me the feedback on the comment section. You can also ensure that you subscribe to Top Grade Academy YouTube channel and turn on the notification bell. I've noted that a majority of us view but we fail to subscribe, so ensure you also subscribe. And in case you are interested in my private tutorials, this is my number here, 0742090825. And for the sake of those who are not within the Kenyan airspace, just take it as +254742090825. You can get me through that number. You can take through WhatsApp. You can text me through WhatsApp, and I can be able to guide you more on mathematics. That is at a cup of coffee price. So are you done? So that we can determine the gradient of a curve at a point. the gradient of a curve at a point. Njeni njogona? The gradient of a curve at a point. Hatujamaliza bado. Okay, let us do it together. dy over dx is equals to, so we will take 3 and multiply it by a third, then x squared, then this one we will take 2 multiplied by 1, so it will be equal to 2x. 2 minus 1 is 1, so it will remain 2x, then minus, when you differentiate 3x it will become 3. So our dy over our dx will be equal to, by 3 1 by 3 1, we have x squared plus 2x minus 3. X squared plus 2x minus 3, not minus 3x. Not minus 3x, and I've already explained that. I want you to understand that 3x itself, so kama uko na 3x uambiwe udifferentiate 3x peke yake, inafaa iwe dy over dx. Unafaa uweke kila kitu, include your 1 hapo. So what is 1 times 3? It is 3. Then x remains there, then the power reduces by 1, so itakuwa 3x to power 0. Tukaongea kuhusu zero index. Zero index states that any number raised to power 0 is 1. So x to power 0 is 1. 1 times 3 is going to give us 3. So there is no way you can differentiate 3x to get 3x. Once you differentiate 3x, you are going to get 3. I hope you've seen that here in Jogona. So with that, I think we can now proceed to the next thing. Finding the gradient of a curve at a point. Gradient of curves at a point. Gradients of curve at a point. You are told to find the gradient of a curve at a point. So we may have some questions. Find the gradient of the given curves at indicated point. Find the gradient of the following curves, of the given curves at the indicated point. At the indicated points. So the first one is y is equals to x squared minus 3x at what point? 2, negative 2. And b is y is equals to x to power 4 minus 3x squared plus 6x into brackets at 0.14, at 0.14. And we can also have the third one, y is equal to x to power 5 minus 7x plus 3 at 0.03. So we have such, and once we have such, what we are going to do is that we will take the first one, a, we want to find the solution, we want to find the gradient. And what do we do to find the gradient? You must first find the gradient function. You must differentiate. So our a is y is equals to x squared minus 3x, and we want to find the gradient at 0.2, negative 2. So once we differentiate this and get the gradient function, it will be dy over dx is equal to, this one is 1, so 2 times 1 is 2, then it will be x, then 2 minus 1 is 1, then minus, if you differentiate 3x, you get 3. So dy over dx, this is what we call the gradient function. Why do we call it the gradient function? Because it is difference of y over difference in x. Remember, in equation of straight lines, we said, how do we find the gradient of a straight line? It is change in y over change in x. So this one now is the gradient function of a curve, dy over dx. And with the point 2, negative 2, we can be able to find it. Why? Because we have our x here as 2. So here we will deal with just our x. So itakuwa dy over dx is equal to 2 multiplied by 2 minus 3. And we will get our dy over dx is equal to 2 times 2 is 4. 4 minus 3 is 1. So the gradient of the curve at this point is equal to 1. It is equal to 1. The gradient will be equal to 1. So having that, mbona tumeweka 2? Because our x is 2. Our x here is 2. Najua unajiuliza mbona hatutumii y, juu tumeambiwa tutafute gradient. So gradient, remember, ni dy over dx. So dy over dx is this function. So we can only substitute the value of x here because we don't have the value of y. We just substitute the value of x and get our dy over dx is equivalent to 1. So let us do number 2. Number 2, b, we have y equals to x to power 4 minus 3x squared plus 6x, and our points are 1 and 4. So for us to find the gradient of this curve at 1, 4, what we are going to do, we will find first our dy over dx. And our dy over dx will be equal to 4. This one is 1, so 4 times 1 is 4. Then x, 4 minus 1 is 3, minus 2 times 3 is 6x. 2 minus 1 is 1, so itabaki hivyo, hakuna haja ya kuandika 1, plus if you differentiate 6x, you are left with 6. And once we get this as our gradient function at 0.14, we will substitute our value for x with 1. And we are going to have dy over dx is equals to 1 to power 3 is 4 into brackets 1 to power 3 minus 6 times 1 plus 6. And we will get our dy over our dx as 1 cubic is 1 times 4 is 4, minus 6 times 1 is 6 plus 6. And we will get our dy over dx is equal to 4. Our dy over dx will be equal to 4. Have we understood? If we have understood, then do the last question. Do part C. Do part C so that we can do KCSE based questions in this area. So do part C. Do part C of the question. negative 7. Correct? Correct? Iko sawa? So we can have some questions here. There is a KCSE question. A curve is given by the equation y is equals to five x cubic minus 7x squared plus 3x plus 2. Find the gradient of the curve at x is equal to 1. 2 marks. That is question 1. Question 2. These are KCSE questions. Given the curve y equals to x cubic plus a half x squared minus 4x plus 1, comma, find the Roman 1 gradient of the curve at one negative a half. And question 3, the equation of the curve is given by y is equal to x cubic minus 4x squared minus 3x. A, find the value of y. So hapa uta differentiate, umembu utafute y. Find the value of y when x is equal to -1. That is 1 mark. So write down those questions, you will do them. So I've said my contact is +254 742 090825 for private tutorials and inquiries. So write down those questions so that we can proceed to the next subtopic. So Muhammad Gausu, this is a scheduled class and it has specific members who are supposed to follow it. So I'm going at a pace of the students that I'm teaching. I cannot go at the pace that you want me to go. I'm having students on board, offline and online, who are following this session. And I'm just teaching as a normal topic would be taught in classroom. So if you want speed, just dial this number and address your issue and your challenge, and I'm going to take you with the speed that you need. And this, I mean, these are private tutorials. They are not just for free. You have an added advantage to access this class for free, but the others who are not accessing it for free. So if there is something that you need me to address to you at higher frequency, just dial that number. Drop a text in my inbox. Let's continue. Njeri Njogona, I hope you have written down the questions so that we can proceed to the next subtopic. I'll send you more and more questions on what we have done via WhatsApp so that you can do that work and submit it for marking. And let's continue. So now I'll be discussing about equation of tangents and normals to a curve. equation of tangents and normals to a curve. Equation of tangents and normals to a curve. So talking of tangent, we mean given a function in form of x and y, that can be our function. When we have such a kind of a function, we can say this one is y equals to 2x to power n. Let's just call it like that. And we have a point here. So what is a tangent? A tangent is a straight line that touches a specific point on a curve. A tangent is this straight line. That is what we call a tangent. A tangent is a straight line that touches a particular point of a curve. It touches the locus of a curve. It touches the locus of a curve. So when we talk of tangents of curves, they are just normal straight lines, but those lines are passing through a particular point at a curve, and that point can be x, y. That point can be x, y. So we can be able to determine the equation of the tangent of tangent in contact with the curve simply because we can still be able to get the equation of the tangent because the gradient of the tangent ilaini na the gradient of the curve at the point of contact is the same. The gradient of the tangent and that of the curve at the point of contact is still the same. So what we are going to do is that we now do some examples. We'll do some examples based on that. Find the equation of the tangent to the given curves at the indicated point. At the indicated point, a y is equal to x cubic plus x squared plus 1 at 0.13. So we are finding the equation of the tangent to the given curve at that point. So this means that if we can sketch this one out, we have a Cartesian plane in form of x and y. This one is 0. And we have our curve here. We can name our curve. I've just sketched the curve. X cubic plus x squared plus 1. Then we have a 0.13 here. And our tangent may be passing through that point. So our tangent is passing through this 0.13. Our tangent, we said, is a straight line. So for us to determine the equation of that tangent, what we are going to do, we will get y is equal to x cubic plus x squared minus 1. We will find the gradient function of this. So we will do dy over dx is equal to x. So how do you find dy over dx? It is 3 times 1 is 3, x squared plus 2x. 3x squared plus 2x. And also remember, it is at 0.13. It is at 0.13. So we will first find the gradient of the curve at this point. So it is when x is 1. And we are going to get dy over dx is equals to 3 into bracket 1 squared plus 2 into bracket 1. So our gradient of the curve at this 0.13 will be equal to 1 squared is 1 times 3 is 3 plus 2, which is equal to 5. Our dy over our dx is equal to 5. So once we get our dy over dx is equal to 5, we had done that in our first questions when we learned about finding the gradient of a curve at a point. So tukipata gradient ni 5, gradient ya curve ni 5 na bado gradient ya tangent ni 5, juu zote mbili ziko at the same point when x is 1. When x is 1. So after you get that, now we can now proceed to find the equation of a tangent. Remember we said a tangent is a straight line, and we know how to find the equation of a straight line in form of y equals to mx plus c. So what we are going to do now, we will take the point of contact 1, 3. Our gradient is 5 over 1, and our arbitrary points are x and y. And our arbitrary points are x and y. After we get that, we will now take y minus 3 over x minus 1 is equal to 5 over 1. Is equal to 5 over 1. So what are we going to do here? We cross multiply and we get y minus 3 is equal to 5 x minus 1. So 1 times y is y minus 1 times 3 is 3 is equals to 5 times x is 5x minus 5. And the equation of a tangent will be y is equals to 5x minus 5 plus 3. So our y will be 5x minus 5 plus 3 is equal to minus 2. Is equal to minus 2. And we have determined the equation of our tangent. We have determined the equation of our tangent. We have determined the equation of our tangent. Let us have the second example. Let us have our second example. So our second example will be, find the equation of the tangent to the given curve at the indicated point. Y is equals to x cubic plus 3x squared minus 3 when x is equal to 2. 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 So what we are going to do here, Njeri Njogona, in this case, juu hapa ujapewa y, kwanza tutafute y to make work easier. Kwanza tutafute y when x is equal to 2. So our y itakuwa 2 cubic plus 3, 2 squared minus 3. So that we get our y as 2 cubic is 8 plus 2 squared is 4 times 3, 12 minus 3. So we get our y as 8 plus 12 is 20, 20 minus 3 is 17. So that we can now have our equation as y is equal to x cubic plus 3x squared minus 3, and our coordinate is 2, 17. Mbona tumetafuta y? Ni juu tukienda kutafuta equation ya tangent tunahitaji tuwe na coordinate yetu in form of x and y. So that's why tumetafuta y kwanza. So what we are now going to do, we now find our gradient function dy over dx. So for you to determine dy over dx, you know it is obviously 3 times 1 is 3x squared, then plus 2 times 3 is 6x, then the 3 constant itaisha. So we will get that, and in this point our coordinates are 2, 17. we will find dy over dx when x is 2. When x is 2. So dy over dx when x is 2 will be 2 squared is 4. 4 times 3 is 12. Plus 6 times 2 is 12. So our dy over dx is equal to 24. So don't forget that the gradient of the curve and the gradient of the tangent at point 2, 17 is 24 in both cases. So we will now have 217 with the gradient of 24 over 1, and the arbitrary points are x and y. X and y. And we will get y minus 17 over x minus 2 is equals to 24 over 1. And once we cross multiply, 1 times y minus 17 will remain to be y minus 17 is equals to 24 into bracket x minus 2. 24 into bracket x minus 2. So y minus 17 will be equivalent to 24 times x is 24x. Then 24 times 2 is minus 48. So that will be y is equals to 24x minus 48 plus 17. So what is minus 48 plus 17? You get your y as 24x minus 48 plus 17. It is equal to negative 31. It will be equal to negative 31. And we are done. Jerry Njomona, have you understood on finding the equation of the tangent? Tumeelewa equation of tangent. Remember, unaona inapelekana na equation of lines. So tangent is a straight line. Have you understood? If you have understood, just drop it down on the comment section so that I know you've understood. Have you understood, Jerry Njomona? Umeelewa? Let's do some KCSE based questions. So kama umeelewa hiyo, let us learn something about normals. Ili maswali nitakupatia hiyo imeshikana. So what are normals? So what is a normal? A normal is a perpendicular line to a tangent. It is a perpendicular line to a tangent. A normal is a perpendicular line to a tangent. So if you have the function x, y, and you have your curve here, and this is your tangent, and having this as your tangent, this is your point of contact, what happens is that a normal is another straight line that is perpendicular to a tangent. When we talk of a perpendicular line, it means that the two lines intersect at right angle at the same point. They intersect at right angle at the same point. And I know once you come across the word perpendicular, you understand because we have interacted with gradient and equation of straight lines. We have interacted with gradient and equation of straight lines. So what we are going to do in this particular case is just but the same thing. Remember, when you see perpendicular, it means that m1 times m2 is equal to negative 1. m1 times m2 is equal to negative 1. m1 times m2 is equal to negative 1. So we can have such a question on normals. There is a question here. Question is asking the equation of a curve. It's a KCSE question. Sorry, not the gradient, the equation. The equation of a curve is y is equals to x cubic plus x squared minus x minus 1. Determine Roman 1 the equation of the tangent to the curve at x equals to 1. 3 marks. 3 marks. So how do we go about this? The equation of the tangent. We said our function is y equals to x cubic plus x squared minus x minus 1. And once we get that, it is x plus 1, our value of x. So we first find the value of y. So y will be equal to 1 cubic is 1 plus 1 squared is 1 minus 1 minus 1. And we will get 1 plus 1 is 2. Minus 1 is minus 2. So our y is equal to 0. So we are now going to deal with y equals to x cubic plus x squared minus x minus 1, where our our coordinates are 1 and 0. So we are now supposed to find the equation of the tangent at this coordinate. So we said we are going to do dy over dx, and once we find the derivative, we will get 3 times 1 is 3x squared plus 2 times 1 is 2x to power 1, so it is 2x, minus the derivative of x is 1. And remember, it is at 0.10. So we will take x, which is 1, we replace here and find the gradient. So our dy over our dx will be equal to 1 squared is 1, 1 times 3 is 3, plus 2 times 1 is 2, minus 1. Minus 1. So our dy over our dx will be equal to 3 plus 2, 5, 5 minus 1, 4. So we have gotten the gradient as 4. We've gotten the gradient as 4. So after getting the gradient, we now need to find the equation of the tangent. The equation of the tangent. So how do we find the equation of the tangent? The coordinates are 1, 0. The gradient is 4 over 1, and the arbitrary points are x and y. Arbitrary points are x and y. So we will take y minus 0 over x minus 1 is equal to 4 over 1. Then we cross multiply. And when we cross multiply, we are going to get we will get y minus 0 times 1 is y equals to 4x, 4 into bracket x minus 1, and y is equal to 4x minus 4. And that is the equation of the tangent. That is the equation of the tangent. So this Roman 2, we are supposed to find the equation of the normal to the curve at x is 1. The same to the normal at x is 1. So at least we have known that our coordinates are 1, 0. So for us to do Roman 2, we need to know that a normal, we said that a normal is a perpendicular to a tangent. Normal is a perpendicular to a tangent. It is a perpendicular to a tangent. So when we say that a normal is a perpendicular to a tangent, we simply mean that m1 times m2 is equal to negative 1. So having our m1, our gradient 1 is 4, times m2, we can be able to get our second gradient, which will be 4m2 is equal to negative 1, and the gradient of our normal will be equal to negative a quarter. Negative a quarter. So far, have you understood? It will be negative a quarter. So once we get our gradient as negative a quarter, remember they are perpendicular at the same point 1, 0. The gradient is negative 1 over 4, and the arbitrary points are x and y. So what are you going to do? We have y minus 0 over x minus 1 is equal to negative a quarter. So once we cross multiply, you have 4 into brackets y minus 0 is equal to negative 1 into bracket x minus 1. And that is going to give us 4 times y is 4y is equal to negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. And once we have that, we can divide by 4, by 4, by 4, and we'll get our y as negative 1 over 4x plus 1 over 4. Plus 1 over 4. That is how we go about that question. I hope you've understood. Okay. Tulikuwa tumesema tutafika hapo Njeri Njogona. And what we are going to do, I'm going to send you some work on what we have done. Tumeenda halfway. Hiyo ingine imebaki. Tumebakisha stationary points or turning points, curve sketching, na tumebakisha applications of differentiation na maxima and minima. So whatever we've done today is enough. Let me not keep on bombarding you with a lot of information. So this one now we are going to do in our next lesson. Yes. So I want to wish you a good day. You can rate the class. How has the class been? How was it? Was it interesting? How was the class? So I want to wish you a good day ahead. We are going to meet in the course of the week as I give you some work to do on differentiation. So have a good day.